Let's have a look at question 6a. So you were given a differential equation and you need to show that the solution of this differential equation is in this form here. So again, you start off, what is your dependent, what is your independent variable? Your dependent is S, your independent is P. If you cover up the derivative and you look at the rest of the equation, you have 1, 2, 3 terms. You also have a mixture of dependent and independent. So it's not direct integration and it's not separable either, because you can't change that into two terms, no matter what you do. You also have your dependent variable to the power 1 and then another one to the power 3. So it's not linear either. So this is in fact a Bernoulli differential equation. So the first thing you want to do is get it into standard form. So standard form is your first term, you can only have a 1 in front of the derivative, nothing else. So we divide through by 2. And I'm going to move this as well. All right, and that is your Bernoulli standard form. Now I'm going to take the Bernoulli and convert it into a linear form. So on this side, on the right hand side, I don't want any dependent variable. So I'm going to divide by S cubed. If you come to the left hand side of the equation, I don't want your dependent variable to the power anything else except 1. And there's no way I can change that. The only way I can do it is if I change the variable. So I'm going to say, let z equal s to the minus 2, and then dz dt is going to be minus 2s ds dt. Yeah? So therefore, your equation is going to look like this. Right? The problem you have here again is that you have 1, 2, 3 different variables which you can't work with. But if you look at the first term, it's very close to what dz dt is. The only difference here is the minus 2. So I'm going to say multiply by minus 2. You can introduce it because minus 2 is just a constant. Right? Which means that equation is now linear because your first term is just dz dt minus z t minus 1. And then you use the linear method in order to solve for z. Okay, then we substitute zf equals integral of f times t minus 1 dt z e to the minus t So if you look at the integral that you've got over here, you can do one of two things. You can either multiply out the e to the minus t and then integrate, or what you can do at this point is to do integration by parts. So I did integration by parts, but you can go and have a look at the memo and see how you step through that. So you can fill in this piece over here. It simplifies to that after you do integration by parts. Okay, so now you want to convert this solution here into the form that was given to you before. Remember also that z in this case was s to the minus 2. So s minus 2 So what I'm going to do is I'm going to get rid of the e to the minus t. So it simplifies to 1 over s squared e to the t. Here you get e to the positive t because of your exponential rules. And then we're going to have s squared, multiply that out. Right? Those ones add up to 0, and you're going to have 1 over s squared t plus e to the tc, which is what you were asked to do. So that is the end of the first part of the question, 6a.